I'm Stephen Foskett, and we're here in San Francisco for Cloud Field Day. We're visiting companies in the cloud space, and we've got a panel of invited delegates who are writers, speakers, podcasters, bloggers, that sort of thing. We've invited them to come here, presentations, to ask questions, and to represent the audience that is not in the room. If you're interested in learning more about Tech Field Day, go to techfieldday.com, and you can find lots of videos from our events at youtube.com/techfieldday.
Welcome. My name is Michael Friis. I'm a product manager at Docker. I joined about 8 months ago, and I'm working on a lot of the stuff that we're doing with Microsoft. So that is the work we're doing to port Docker Engine to Windows, making sure that .NET is great with Docker, that Visual Studio does the right things with Docker, and also that Docker has a good experience on Azure. The stuff I'll cover today mostly, though, is the new kind of Windows Server things that are showing up where Microsoft has added containerization primitives to the Windows kernel, and then Docker Engine has been ported to Windows and can be used to manage containers on Windows. So feel free to interrupt at any time if you have questions. And so this kind of shows the whole picture. Specifically regarding Docker and the stuff we're doing on Windows, the goal on our end is that fundamentally you're going to need a Windows system to run Windows containers and a Linux system to run Linux containers. But what we can do with Docker is that there's going to be one set of APIs, one set of tools, CLI tools, one registry. All these formats are going to be the same across Linux and Windows when you're using Docker. So Docker is going to be one tool set and one set of APIs and image formats that you can use to build, ship, and run apps on both Linux and Windows. And then as I mentioned, we're also doing work with Visual Studio to make sure that Visual Studio is great for developing both Linux and Windows container apps, and we're also working with the Azure guys to light up Docker on Azure. Have any of you tried Windows Server 2016? Okay, quite a few. Cool. So it's in tech preview right now, and
GA next week. No, 2 weeks.
Yeah, I can't confirm those rumors, but
it's public. It's public.
Yeah. So that'll hopefully be GA soon. In terms of Docker, that's a long prehistory. Microsoft and Docker formed a partnership in 2014. So this has been a long time coming. And what's happened in those preceding 2 years is that Microsoft went and implemented containerization primitives in the Windows kernel. So actually, if you updated to the Windows 10 Anniversary Edition, which came out like a month ago, the Windows 10 kernel now also has containerization primitives. And you can start and stop containers on Windows 10, and then it's showing up in Windows Server 2016. So Microsoft did that work in the Windows kernel, and then together, Docker and Microsoft ported the Docker engine to Windows. So the CLI was the first thing to run on Windows, but now Docker engine just runs raw on Windows, and that's what you can use to start and stop containers in Windows. And this is
going to have the new swarm mode as well?
Yeah, great question. So I suspect at launch, swarm mode will not, swarm init on Windows will not work out of the box. But we're working with Microsoft to get that working. Basically, there's a few things missing in kind of the Windows overlay networking implementation. But we're actually getting pre-builds from Microsoft already where this stuff is showing up. And it's obviously both extremely important for both us and for Microsoft to get this working. Coming soon, hopefully.
So the Microsoft containers and Docker containers are effectively two different containers, but they're compatible APIs and can run.
So really, the way we think about it is that it's all Docker containers.
They're all Docker containers.
Yeah. So, but if you build a Docker container on Windows, that won't run on Linux, and a Linux container won't run out of the box on Windows either. Right. So because the way containers work, right, is that the kernel is shared. So to run a Windows container, a Windows Docker container, if you will, you fundamentally need a Windows kernel. And then the other way around, so while the raw containerization primitives exist in the Windows kernel, there's not really any other way than Docker to use them. So if you just boot up a naked Windows Server 2016, you can't start a container without first installing Docker.
So is it like that Docker is the user space tooling to be able to use?
Yes.
Okay.
Yeah.
Well, that's the shift over, because the old version was, if you did the early release, you had PowerShell commandlets, and you had the old command line form factor for doing native Windows containers, not Docker containers on.
Correct. So up to TP4,
Right.
there were two ways to run containers on Windows. You could install Docker and use Docker, or you could use the PowerShell commandlets that operated the native Windows kernel APIs directly. In the interim, Microsoft, I think they just wanted to focus on the Docker story.
Right.
So that's the only way you can do it right now.
Right.
But then actually, Microsoft went.
But they're going to put a wrapper around that.
It's already there. So you got Windows Server 2016, then you're running Docker. And then from here, you can kind of use the Docker CLI. But they also built what's called PowerShell for Docker.
Right.
But PowerShell for Docker operates the Docker Engine API.
Yeah.
So it's just convenience. Like if you really like PowerShell, then you can script the Docker Engine using those commandlets. And by the way, the PowerShell for Docker commandlets, you can use those to script a Linux Docker Engine also, because it just uses the standard Docker Engine REST API.
Yep.
Yeah, good question. Where did I get to? And so as I mentioned, all of this happened in the open on Docker, and there's now a Microsoft employee that's a core maintainer of Docker, John Howard, and Microsoft's made enormous contributions to the Docker engine.
Now, how's that different from Azure?
How is that different from
So,
Azure?
like, is Azure have much the same sort of constraints for running containers that running it on Windows Server 2016? Or
Well, there's like a container engine there.
Well, so Azure has
Docker container engine running on Azure?
No, Azure Container Service is actually the Linux implementation of Docker with either Docker Swarm or Mesos.
Yeah. So Azure Container Service is
Today.
it's just like a way to set up a bunch of Linux machines with Docker on them in a swarm that you can then go run Docker Linux containers on. They also have Windows support in preview. So yeah.
How are they running? How are they running Azure itself though? Like that's a different question altogether. So
Yeah.
Service Fabric.
yeah, it's Service Fabric, but yeah.
All right. So with this we have Docker Engine running on Windows Server, and then kind of all the ancillary services that we run, like registry, DTR, Hub, Docker Hub, kind of already have what we call MultiAAG support. So this actually started a long time ago, even before the Microsoft partnership, I think, where we wanted the registries and the way images work to be multi-AAG aware, so that you can have, say, x86, 32-bit x86, ARM, Solaris, IBM, System 390 images side by side, and so we co-opted that for Windows. So basically now, for some images, what we'll get to is that you can just do Docker pull Golang, for example, and that'll get you, if you're on a Windows system, that'll get you a Golang image for Windows, and vice versa on Linux.
If I'm creating my own templates to be deployed though, sorry, my own images, do I have to basically compile a Windows image and a Linux image if I want both?
It's up to you. So, like, if you know you're going to be deploying to Linux, you should just create Linux images. But say you were a community maintaining a programming language and you actually cared about Windows, then you would, well, or I mean, we're already doing this. Then you're gonna, you'll have to have toolchain and a tooling setup that runs on both Linux and Windows to be able to create those Windows images.
So yes.
Yes.
Okay.
Yeah.
Is Docker Data Center and UCP going to support this out of the gate?
For the same kind of networking reason, it won't support it out of the gate. at launch. But as I mentioned, we're working extremely hard to get that working. Okay. It's I don't know how interested you are, but just to give you an idea of the work that was done, this is how stuff works on Linux, right? You have Linux, then you have some Linux primitives, and then the Docker engine runs on top, manipulating those images and exposing a REST interface to the various tools, that Docker has. On Windows, it's the same, or it's similar. So Microsoft went and added similar primitives in the Windows kernel, and then we collaborated with them to port the Docker engine to manipulate those new kernel primitives. And then all of this is it's the same, of course. Yeah, it's just a comparison showing the differences.
The one you just had. One doing both. Yeah.
So on the Microsoft guys actually did something interesting when they implemented containers on Windows. There's two runtime modes that you can choose when running a container. You can either choose to run it as what's called a Windows Server container, which is the exact same model as on Linux. You're using all the containers running on a system, all the Windows Server containers running on a system are sharing a single Windows kernel. They're running side by side, but in full isolation. They can't see what other containers are doing, and so on and so forth. But there's also a different model called Hyper-V containers, where and it's just a command line switch. Like to start a Windows Server container, you do docker run nginx, say. To start a Hyper-V container, you do docker run -- isolation equals Hyper-V nginx. And it's the same image, and it's the same commands, it's the same API. So it's just kind of a runtime switch. But what that switch does is that it actually starts a very lightweight Hyper-V VM with its own very minimal kernel. And then the container is deployed inside of there and running. So you get slightly better isolation but then on the other hand, it takes a little longer to kind of start up.
Why would I do that?
Yeah, good question. So for example, if you're paranoid
Is a Docker container engine running in the Hyper-V, or is it a Docker container?
No, the Docker container is always just. Oh, sorry. The Docker daemon is always just running in userland on the system.
That's kind of what.
But then it's starting this type of container. So there's no kind of Docker software inside of this.
So if you're running
the same use case, right? If you look at vSphere integrated containers,
yes,
it's the same use case. You're used to virtual machines, and you want that to be the boundary and apply those same security policies.
Yes,
that's one.
Yeah, I mean it's more common as multi-tenant. If you decide you want to run Docker provided on a hypervisor level constraint, and you want to be able to allow people to spread workload across all your resources, you're going to use the Windows kernel mode configuration to be able to do that, because everyone is then fully locked in their own Windows kernel set. Lead over.
Yeah, I think the main reason you do it really is if you have very strict isolation constraints. So, like, say maybe it's a hostilely multi-tenant platform, then you get slightly better isolation this way. Or say you happen to run your WordPress site next to your payment processing container app site, then you could choose to deploy your billing processing inside of Hyper-V containers because if you think that's going to get you better isolation.
Do you see people doing that, or possibly doing that due to better resource controls in a hypervisor, or say better software-defined networking capabilities within the hypervisor level than you can get within, say, a standard container on an OS?
So from the standpoint of operating the Docker API, the things you can do are the same. You can apply the same resource constraints, and the networking works the same also, which is really important for us. So it's really about the isolation, I think. Yeah.
Isn't this a use case for kind of cross-platform containers as well?
So what you're saying is, well, could this run a Linux container? It doesn't right now.
Well, it kind of does. So if you look at Mac for Windows or Docker for Windows or Docker for Mac, that is specifically what it's doing.
Yeah, but that's a different set of technology though. But I hear you.
It's a very small difference.
Yeah, I would argue otherwise, but
Yeah, no, the Hyper-V container configuration with Hyper-V for the hypervisor underneath, it's still partitioning out the same Windows kernel that it spawned off for itself. So it's still.
Yeah. Also, like Docker for Mac and Docker for Windows, inside of that Linux VM, that's just a convenient way for us to get you a Linux system onto Mac or Windows,
I get
and it then runs multiple containers, right? Each time you spin up one of those, it's a new hypervisor, and it's just one container running inside of it.
Okay, yeah.
But it's not. You're not completely wrong, but yeah.
Quick question.
Yep.
In the Linux world, if you wanted to, appreciate it's a little bit hard work right now, but you can lock containers down using seccomp. Is there an equivalent in the Windows world if you wanted to try and lock native containers down without running Hyper-V containers?
So I think that's actually the best analogy, really. Like when you decide between Windows Server containers and Hyper-V containers, it's because you have similar concerns to the concerns you have if you apply a different seccomp profile.
I get that, but there is.
I don't know. I don't think there's switches exposed to do similar stuff to seccomp.
Like to shut off syscalls and stuff.
No, I'd have to check. I can check up on that. Yeah. Cool. Anything else I should say about this?
Do you see them like using something like the Windows firewall to control access to containers sometime in the future? Or?
That was kind of where I was driving at with some of the isolation.
Well, but like, I mean, you're doing the same thing with IP tables in Linux.
Right.
Yeah, so why not?
Because you are a Windows shop and you already know how to manage the Windows firewall.
No, I mean, why not use Windows firewalls?
Yeah.
Oh, I'm sorry.
It's too high a level, though, isn't it? Because the Windows firewall, in essence, is running at a higher level in the operating system.
Oh, you can run one in the Hyper-V hypervisor.
That's
so
what
True.
So if you're running Nano, even in Nano, you can do that. It's not domain control, but you can do the ugly PowerShell and actually make it work.
And that's what I was asking about, doing the VM containers is, I'm a VMware guy, right? So, if you swap this out with vSphere and put NSX under this and did microsegmentation under that, maybe that would be a reason to have that use case.
I don't know if I would use the NSX. They already have an overlay done with load network, so you don't really need that use case.
You don't have to do overlay with NSX. I could use all the other security functions without the overlay.
Sure. Yeah.
I'm also coming at this from an enterprise mindset, right? I've already, we've got customers that have built these kind of on-premises clouds with these tools, and now they want to kind of move to a container model. How do we leverage what they've got against?
Yeah, I probably leverage what was native built in VMware before I would leverage native built what's in Microsoft, unless you're already a Microsoft shop converting to Hyper-V, and then you would adopt this model set, and then that's taken care of for you on that side.
I agree with that.
You don't have to worry about it. That's at least how I would tackle it, because I'm lazy.
Efficient.
It's a lazy architect.
Okay. Cool. Yeah, that's actually all I had. I don't know if you have more questions.
Yeah. So I'm going to do it now. So Windows has awesome v6 capabilities in it, and on the IPv6 side, the Windows kernel side, everything else, libnetwork has some deficiencies in terms of doing large-scale v6 components correctly.
Okay.
Is there going to be improvements on that? Obviously, Linux has good v6 support too, but for this, everything within Windows, it's a different built networking stack, right? Because it's a dual IP layer stack. You can't pull v6 out. It's not actually possible to turn v6 off in the Windows stack.
Right.
So what's going to be the story going forward for those that are already running dual stack implementations, and how's that going to be supported with Docker in these implementations?
I don't have a good answer for you. I'll have, but if you want to send Betty a note, we can follow up.
And are you working with? And is Dave Thaler helping you out on the networking stack side, on sort of, because he was the original COSD developer for the networking stack?
We're working with the Windows kernel networking team. I don't know that name.
Okay. It's probably Dave and Abelati did the original work on it too. So, all right.
Yep. Betty, if you wanna, we should follow up.
Okay.
You just fix it yourself, Ed. You should just do it now.
Do it now.
I'm gonna file a PR.
But I mean, in general, we'll make sure that libnetwork works great on Windows and is doing the right things.
I'll harass Madhu later. So.
Okay. Yeah, that's the guy you want to talk to. Yeah. Okay, cool. Other questions?
Yeah, one more from the audience watching back home. So there's a question about the multi-arc stuff. So it is coming.
It's already there, actually. I posted a blog post on the Docker blog maybe in March or something.
Yeah.
So it's already on Docker Hub. There's kind of prototype tools that let you create multi-arc images and push them to Docker Hub.
Right.
And there's not a lot of UI support on Docker Hub, but basically like everything from the registry down, the registry, the engine works fine.
Right.
And just to get into the details, the way it works is that basically you create what's called kind of fat manifests. So it's instead of a image manifest that just has some metadata and a bunch of layers, you create a fat manifest which has some metadata, and then it references several sub-manifests. For example, one for Linux and one for Windows. And then when you do, say, Docker pull Golang, the registry will present to you the fat manifest, and then your engine will look at that and say, oh, I'm a Windows engine, so I should go grab this image, and then it goes and pulls those layers.
Exactly, and that's in there right now already.
Yep, you can use it. Yep, go check out that blog post.
Can you get Betty to mail us the link to that, please?
Yeah.
Yep.
That would be super.
Sitting right behind you.
Sorry.
Yeah, and actually Phil Estes from IBM built the tool that can compose the fat manifests. It works nice.
Nice.
Yeah.
Are you guys thinking about doing anything for those that have already made the investment on the DSC side of doing convert overs for DSC into sort of the Docker format?
Remind me what's DSC?
The desired state configuration. So if you pre-built desired state configuration for standing up and delivering how your app wants to exist, so you're going in and deploying applications on top of Windows Server, you can use DSC to go ahead and get that stuff populated through. It would be sort of interesting to see. I mean, it'd be a one-way conversion, like sort of one-time thing, but it might be sort of interesting to see.
That's a good idea. So that would generate something like a compose file or a DAP file?
Right.
That's a good idea. We haven't looked at it, actually.
All right.
That's a good idea. Thanks.
Hey, and with Windows kernels, with Windows containers, do you still have to pull a base image as like?
Yeah. So actually, for a long time, the way it worked was that this is complicated. So the base images were kind of custom, and they were just presumed to be on the system where you were going to be running containers. And then the only thing you push and pull were the kind of user land layers.
Yeah.
So luckily that got changed now. So actually, if you go to Docker Hub, you will find an image that is called Microsoft/Windows Server Core and one called Nano Server. And you just pull Microsoft/Nano Server, and that pulls the Nano Server base image. So on Windows, so like on Linux you have Scratch, which is basically a image with nothing in it. On Windows it's slightly different.
It's 9 gig.
Well, yeah. So
the Nano version's like 900 meg or something, but it's still relative to the Linux-based images is ridiculous.
They're a little larger. So yes, and that's a bit of a bummer. But what I found actually is that like as opposed to Linux, you end up getting that base layer once, and then because of the layer sharing, it's not really a problem, right? Because then all the other images that you're going to have are just going to sit on top of that base layer, so you get it once and then you're good. Whereas on Linux, you might have a bunch of images based on Debian, some on Ubuntu, and some on Alpine, and you have to go fetch the base userland for all of those different distros to be able to do something useful.
But I can run it. So I would run a Windows Server 2016 in all of its full fat glory, and I would still have to pull, if I didn't want to go with Nano Server as the base image, if I wanted to go with Windows Server Core, whatever it is, I would have to pull another 9 gig down. I can't just let.
That's true.
So
why?
Maybe explain the whole concept of the base image entirely, because the way I've looked at containers for the longest time is you've got your base file system, not in an image, but on the host. Why download anything at all?
Yeah, because you've already got that
You've
entire
got
Windows
file
kernel and file
in there.
system. Yeah.
This is for me the biggest difference is between general containerization versus what Docker is doing.
Right.
It's that base image which confuses me all the time.
But I mean, so I'm not an expert on this, but I think if you just start the Scratch image, there's all of the kind of device file system parts, but there's no userland. There's no user.
But in pure containerization, there is. You just see the entire file system in a read-only mode. And from that point, you can carve out stuff that you can read-write to. Or
I don't think that's the case if you start the scratch image.
Yeah, but it's got nothing to do with a scratch image. So before Docker started using images, it was just the root file system underneath the host file system that you had read access to. So then you can, hide parts or make parts read-write. But that's the main difference between pure containerization and what Docker is doing, is the whole concept of a base image, which in the Windows world is leading to, 900 megs or 10 gigs of downloads, which confuses me because the host already has that file system.
Yeah, it's whether you trust that originating host. And for Hyper-V, you're going to run on core and you're not going to have all the bits. So you may have to pull down the bigger originating base image in order to start from there.
Yeah, but that's part of your application image, right?
But I mean,
because you've got a dependency somewhere.
But it might lead to kind of incompatibilities. I see what you mean, but say that model was used, then somebody might take a Windows Server 2016 and decide to do a spring cleaning, and then you pull an image that has actual dependencies on the normal Windows Server 2016 userland, and then it wouldn't work.
Yeah, okay. I get what you're saying.
Yeah. So I hear you, but
I get the trade-off.
Yeah. So for consistency, I think this is kind of the most consistent model.
Yep.
And to get back to your question, like why do you have to re-pull it? I think part of it is also like a really neat thing that you can do actually is you can have a Windows base OS, but then you get to run different versions of the Windows userland. So like say that's a service pack or something, you can actually run container userlands on Windows Server that don't necessarily match that on that of the host. So you can have different patch levels, stuff like that. Or you can run. I think eventually you'll be able to run Windows Server Core on a Nano Server image and vice versa. You can definitely run a Nano Server already on a Windows Server Core image.